So the repeated nearest neighbor is a bit of work. And usually I like to start with in alphabetical order. So I'm going to start with vertex A. And using the repeated nearest neighbor starting at A means from A, what's the cheapest place to go? And for my graph here, I have a choice of 4, 7, 12, or 10. So the 4 is cheapest. So I would go from A to E, the cost of 4. From E, I would go to, let's see, D to E looks pretty cheap. And my options are 1, 14, and 3. I can't go back to A. So 1 is cheapest to D. From D, I can't go back to E or A. I need to pick a vertex I haven't been to yet. And so that's either 6 or 15. So the 6 is the cheapest to B. And then from B, I really only have one choice to get to C and then back to A. So B to C for 8. And then I can get from C back to A to finish this off. C to A is 12. So I have A, B, C, D, E, starting and ending at A. The cost of this one is that sum up there. So that's going to be 11, 19, 31, looks like for that. And we keep doing this starting at a different vertex until we find the cheapest one. And we won't know we found the cheapest one until we've done them all. So starting at B, the cheapest thing to do would be go to E for a cost of 3. From E, we know we can get to D with a cost of 1. From D, let's see, we can either go to C or A, 7 versus 15. So we'll take 7 to A. And then the only thing I haven't done here is hit C yet. So from A to C is 12. And then I can get back to B for 8. And I have my A, B, C, D, E, starting and ending at B. The cost of this one is 10, 11, 23. Oh, it's also 31. Interesting. Slightly different configuration. All right, then we go again. This time we'll start at C. From C, the cheapest thing to do would be to go to B for 8. From B, the 3 seems cheapest to E. From E to D, we love that 1. And I'm getting close to the end. I only have, let's see, what haven't I done? C, E, A hasn't been hit yet, so we have to go from D to A next. That's 7. And then A can take us back to C for 12. So A, B, C, D, E, starting and ending at C, looks good. Adding this up, I get, let's see, 8 and 3 is 11, 12, 19, 31 again. All right, so next, A, B, C, D. Starting at D to E, love that 1 there. And then from E, 3 to B is cheapest. From B, we can't go to D or E, so it's going to be C or A. So we're going to choose C. 8. And then we're starting to run out of letters, so I got to get back to A before I can get back to D. So C to A is 12, and A to D is 7. Starting and ending at D, I have A, B, C, D, E. All the letters are there. Repeats except for the start and the end. So what is this? 4 and 8 is 12. 12 is 24, and 7 is 31 again. Wow. Okay. Almost done. Starting at E, we're going to go to D for 1, and then B for 6. From B, I can't go back to E because I've already, that's where I started. I could go to C or A, so I'm going to have to go to C. It's cheapest from B. And then from C, I haven't hit A, and I'm getting close to the end here, so I have to hit A. C to A is 12, and then finally back to E. A to E 7, 15, 27, and 4 is, every one of them is 31. Wow, that's kind of cool. Instructions. We did the repeated nearest neighbor algorithm above here, starting with which vertex or vertices produces the lowest cost circuit. So in this one right here, it doesn't matter which vertex, I could start at any one of them. So I could start at A, or B, or C, or D, or E. I would check all of them off for this one here. That would be my answer. Check, 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 check.
And so